So this video is going to talk about resistors in series and in parallel, and this is in chapters 29-3 and 29-4 of the textbook. Alright, so equivalent resistance. So this is actually quite similar to when we talked about equivalent capacitance back in chapter 27. So if you have resistors in series, so remember series just means one after the other. So the top resistors here are in series. There's one after the other, after the other, after the other. So if you have resistors in series, the equivalent resistance is just the sum. So you just add up R1 plus R2 plus R3 plus R4 plus however many resistors you have in series. And remember, when we're doing circuit analysis, we'll do some examples of this in class, but what you can do is you can always, to analyze the circuit, you can replace resistors in series with an equivalent resistor that's just the sum of the individual resistances. Now, the other thing when you're analyzing circuits that's important to remember, whenever you have circuit elements in series, the current through each one has to be the same. So, and that's really just a statement of conservation of charge, right? If you're a little charge moving through here, well, if you go through resistor 1, then you have to go through resistor 2 and resistor 3. So whenever you have circuit elements in series, the current through each one is going to be the same. Now on the bottom here, we have resistors in parallel. So one side of the resistor is all connected together, the other side of the resistors are all connected together. So resistors in parallel, well, 1 over the equivalent resistance is the sum of the reciprocals. So 1 over R equivalent is 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus however many other resistors you have. So you're adding reciprocals, and just remember, don't forget, you add all the reciprocals and then you need to take the reciprocal of that to get the equivalent resistance. Now for resistors in parallel, it always pays to remember that the voltage across each resistor has to be the same. So, and really that's just a statement of conservation of energy. Okay, so, and if you have some circuit that's a combination of series and parallel, the way you go about it is the same way as we had with capacitors, so you just simplify things step by step. So you look to see, okay, do I have any resistors that are in series, and you replace that with an equivalent resistance. And do I have any resistors in parallel, and you replace those. And you just go step by step until you slowly simplify the circuit.